The aim of this lecture is to give you an overview of existing additive manufacturing process categories. After this lecture, you will be able to describe how different process categories make use of different types of materials to shape a product's geometry. You will also recognize which type of material is used in different process categories. There are multiple processes developed for additive manufacturing, which vary in material, process, final shape, surface finish. According to European standard and ISO 17296 Part 2, these are grouped into 6 basic categories based on material and machine technology used: VAT photopolymerization, binder jetting, material jetting, material extrusion, powder bed fusion, and directed energy deposition. VAT photopolymerization is defined as an AM process in which liquid photopolymer in a vat is selectively cured by light-activated photopolymerization. The feedstock is a liquid photoreactive resin, with or without filler, typically activated by an ultraviolet radiation from lasers or lamps. The ultraviolet light is used to cure or harden the resin where required, with the platform moves the object being made downwards after each new layer is cured. Material jetting is defined as an AM process in which droplets of build material are selectively deposited. The feedstock is a liquid photopolymer or melted wax, with or without filler. The binding mechanism is a chemical reaction bonding, activated by a radiation light source, or adhesion by solidification of melted material. Material is jetted onto the build surface or platform, where it solidifies and the model is built layer by layer. Material is deposited from a nozzle, which moves horizontally across the build platform. Binder jetting is defined as an AM process in which a liquid bonding agent is selectively deposited to join powder materials. The binder jetting process uses 2 materials: a powder-based material that is polymer, metal or ceramic, and a liquid binder. The binder acts as an adhesive between powder layers. A printhead moves horizontally along the X and Y axis of the machine and deposits alternating layers of the build material and the binding material. After each layer, the object being printed is lowered on its build platform. Metals and ceramics are commonly consolidated by sintering and infiltration with melted material. Material extrusion is defined as an AM process in which material is selectively dispensed through a nozzle or orifice. The feedstock is typically a thermoplastic filament, and binding occurs through thermal reaction. Material is drawn through a nozzle, where it is heated and is then deposited layer by layer. The nozzle can move horizontally and the platform moves up and down vertically after each new layer is deposited. It is a commonly used technique used on many inexpensive domestic and hobby 3D printers. Powder bed diffusion is defined as an AM process in which thermal energy selectively fuses regions of a powder bed. The feedstock consists of various powders, thermoplastic polymers, metal alloys, or ceramics. The thermal energy is transferred from laser or electron beam. Powder bed diffusion contains a range of technologies. The main 3 are SLS, SLM, and EBM. Powder bed diffusion methods all start with a powder bed. A thin layer of loose powder is smoothly spread flat over a build platform. This layer of powder is then passed over by either a laser or electron beam, which supplies significant heat to the powder. Then the build platform changes height, a new layer of powder is deposited, and the process is repeated layer by layer until the part is complete. Directed energy deposition is defined as an AM process in which focused thermal energy is used to fuse materials by melting as they are deposited. The test stock is typically metal powder or wire, and the energy source is a laser, an electron beam, or plasma transfer arc. A typical DAD machine consists of a nozzle mounted on a multi-axis arm, which deposits melted material onto the specified surface, where it solidifies. The principles and process categories described in this lecture refer to commercially available technologies that have proven practically useful and viable on the market for several years.